This video is for my pre-algebra classes. It is over lesson 36, multiplying and dividing integers and terms. So ladies and gentlemen, first of all, let's define what an integer is. And we should already know what that is, but just in case, we're going to review it. An integer, and I'm going to reveal this here, and I want to recommend, because of what we're going to do next, that you do your very best to try to fit this on one line of the paper. So an integer is defined the integers are defined as the natural numbers, or counting numbers, their opposites. So we've got 1, 2, 3, 4, 5, and on and on and on. We've got -1, -2, -3, -4, -5, and on and on and on and on, and 0. And so essentially what we're doing here in this definition is the natural numbers become the positive integers. Their opposites, therefore, are the negative integers. And then in between the positive integers and the negative integers, of course, is 0. So ladies and gentlemen, let's take a look at a problem to start with. Your book might write a problem that would look something like this. Parenthesis, and then a -3 times parenthesis -2, close parenthesis, times parenthesis -1, close parenthesis. Now, a couple things. First of all, since these are all in parentheses, do we need the multiplication dots? No, actually we don't. However, I'm trying to write this like you might see something in the book, which is why I'm putting them in. But no, we would not necessarily need them. We could just have parentheses next to each other to represent multiplication. The other thing is, these are not actually minuses. Remember that subtraction is a binary operation, which means it always has to happen between two things. So I see a 3 here, but there's nothing out front of this. So therefore, this is not a minus sign. Therefore, it must be a negative sign. So this is actually -3 times -2 times -1. And the purpose of the parentheses here are just to group the negative sign with its number. Just to kind of put this in perspective, we've talked about our math pyramid before. And so, we've got addition and subtraction are the weakest operations. We've built off of them because repeated addition is multiplication, and its inverse, division, is on the same step with it. Repeated multiplication are exponents, and the exponent's inverse is roots. And then we have at the very top, we have our grouping symbols. So ladies and gentlemen, when we're dealing with a number and its sign, so it's the negative sign or the positive sign, as far as the pyramid goes, when I say -3, there's a certain strength of that connection. And it's related to our operations. And essentially, it is connected with the same strength as multiplication has in the order of operations. So when you're multiplying two things together, that's the same strength of bond that we have when we have a negative sign with our 3. And so in some ways we could almost imagine this as -3 is almost like saying the negative sign times 3. Okay, it's not right. It's not actually a multiplication sign, but that's the kind of strength of this connection. Okay. Similar to this, but not really part of today's lesson. Units actually have the same strength as multiplication. They're connected to their numbers with the same strength as multiplication. That actually does play out and have some importance. Particularly, we'll see a little bit of that just a second here in the lesson. So anyways, back to this then. So essentially what we have here then is, if I were to rewrite this without the parentheses, I might try to get my negative signs up so that they're obviously not minus signs. So a -3 times a -2 times a -1 And since those negative signs are connected to their numbers with the same kind of strength as the operation we're doing, what's going to end up happening here is that each one of these negative signs is going to tag along to our answer. And so multiplication becomes the tag along operation. And we see this also with units, that units tag along to our answer in multiplication. So if each one of these negative signs tags along to my answer, I have a negative, negative, negative 6. Now here's the thing though. If you have a negative, 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 a negative really just means opposite. So if we imagine that numbers are normally, if we imagine my pen here is pointing to the right, numbers are normally pointing to the right. They normally go off to the right. That's the positive direction. So having a single negative sign would send me the opposite direction to the left. A second negative sign would cancel out the first and send me back to the right. So what we see there is anytime you can buddy up two negatives that are affecting the same number, they're going to end up canceling each other out. So these two right here, we can say will cancel each other out. And so what we're left with then is just that single negative with our 6. So my final answer here is negative 6. Now, how should we write this on the homework? Well, again, I would recommend getting your negative sign lifted up and smaller, so it's obviously a negative and not a minus, times my negative 2 times my negative 1. And I would do the same kind of canceling idea here. I would just do it with what's written here. So take a negative and take a negative, cancel them out. If you can get another pair, cancel out another pair. Well, I can't cancel out this last one. There's nothing to pair up with it. So that means there will be a single negative that will tag along to the answer. And now 3 times 2 is 6, times 1 is still 6. And that's how I would do it on the homework. Try out another one here. This time, let's go negative 4 times negative 5 times negative 3 times negative 2 is what you might see in the book. So again, if we just kind of think this through then, so negative 4 times negative 5 times negative 3 times negative 2, well, multiplication is the tag along operation, so technically all 4 of those negative signs would tag along to the answer. But if I have normal numbers are heading to the right, if I have a negative and then a negative and then a third negative and then a fourth negative, well, we're headed back to the right again, because what's essentially going to happen here is these two can buddy up and cancel, then these two can buddy up and cancel, and so all of our negatives are going to cancel this time. As far as the number goes, since this is multiplication, I would take advantage of the associative and commutative properties of multiplication, which basically will allow us to multiply these in any order we want. So I would do the 5 and the 2 first, because that makes 10. And then 4 times 3 makes 12, and 12 times 10 is 120. And so what would this look like on my paper, though? On my homework, I would copy my negatives, small and high. So they're obviously not minus signs. And again, I would go through like we did here, and I would cancel out pairs of negatives. So we have a pair of negatives here, and we have a pair of negatives here. And when we're done canceling all the pairs, if we have any negatives left over, they'll tag along to the answer. And if we don't have any negatives left over, then the answer must be positive. Well, no negatives left over, the answer must be positive, and we already figured out the number is 120. So ladies and gentlemen, once again thinking about the pyramid, since multiplication and division are related, they are on the same step of the pyramid, there are going to be some similarities in some of their rules. And so what's true for multiplication as far as signs goes turns out to be true for division as well. So in the book, you might see a problem written like this, where they choose to write their division as a fraction. And that's pretty typical the closer and closer we get to algebra. Well, ladies and gentlemen, this is really a negative 20 over 4, because positive 4 is really just 4. Well, kind of similar here. While division, I wouldn't call it the tag-along operation. It is true, though, that your negative signs will tag along if they can't cancel. So there's nothing to buddy up this negative with to cancel them out, which means there will be a negative that tags along to the answer, and 20 divided by 4 is 5. Now, how would I do this on the homework? I would copy my negative 20 like that. I would copy my positive 4 like that. And well, just like we talked about over there, the negative's still going to be there because there's nothing to cancel it out. And 20 divided by 4 is 5. If I have a positive 20 divided by a negative 4, well, likewise, 20 is just 20. Negative 4, though, is a negative 4. And since there's nothing to buddy up that negative with to cancel it out, it'll be part of my answer. And again, 20 divided by 4 is 5. On the homework, it would look like this. Positive 20 is just 20. Negative 4, I'm going to get that negative pushed up. And then, since we have a negative that won't cancel with anything, the answer is negative, and 20 divided by 4 is still 5. All right, next example. Let's say this time we have a negative 20 over a negative 4. So this time, I have a negative 20 over a negative 4. And so there are two negatives to tag along to the answer, making it a negative negative 5. And just like we talked about before, though, two negatives will end up canceling each other. And so then this ends up really just being 5. What would this look like on my homework? So glad you asked. Just like we did with the multiplication, if I have a pair of negatives there, I would just take my pencil and cancel them. And so positive 20 then divided by positive 4 becomes just a plain old positive 5. So, ladies and gentlemen, let's say the book mixes multiplication and division. Negative 3 times a negative 2 all over a negative 5. So in this case, we've got 1, 2, 3 negatives that tag along. So a negative, 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 and then just for the sake of ease for right now, I'm just going to say number. But anytime we've got two negatives in multiplication and division, they're going to cancel. So what would this look like on my homework? I would copy my negatives, small and high. You could use parentheses around your negatives like the book does if you wanted to, just to make it clear. That would be perfectly acceptable. Now from here, since multiplication and division are related, you can cancel out any pair of negatives. As long as it's all multiplication and division, you can cancel out any pair of negatives. So for example, maybe I want to cancel out the 3 and the 5, having their negatives. Well, this is going to leave me with a single negative up top. So 3 times a negative 2, there's nothing to cancel out that negative, so it is going to tag along to the negative 6. Positive 5 is just positive 5. And then, well, since there's nothing to cancel that out, it tags along to my final answer. And then 5 goes into 6 once with 1 left over. So negative 1 1/5. Alternatively, we're going to do this again. I could choose to cancel the negatives on the 3 and the 2. If I do that, then a positive 3 times a positive 2 would be a positive 6. And then that would be over a negative 5, which again, that negative, not having anything to cancel it out with, means my final answer will be negative, and we already know it's a 1/5. I'm going to try to make that a little bit clearer. I don't want that to look like a 7 later. There we go. So ladies and gentlemen, throughout all this, there is a little shortcut that you can use. Personally, I think it's a much more flexible way of thinking about it to do what we've talked about here, where we just think about taking pairs of negatives and canceling them. But the rule for multiplying and dividing integers. So the rule for it, we could sum up in a little box here. So we could have a positive or negative for the first number. We could have a positive or negative for the second number. And so if you multiply a positive times a positive, of course the answer is going to be positive. If you times a positive times a negative, then there's not going to be anything to cancel that negative out. It'll be negative. Same thing if you do a negative times a positive. Nothing to cancel out this negative, so therefore it tags along to the answer and it's negative. If you do a negative times or divided by a negative, then these two negatives will cancel each other out, leaving with a positive. So what we see here is when the signs are the same, you're going to end up getting a positive. So either they're already positive and they stay positive, or they're both negative and they cancel each other out. When the signs are different, it's the negative sign that will tag along to the answer. So ladies and gentlemen, let's flip our papers over. And we're going to talk now real quick about one of those peculiarities of the fact that the negative sign has a strength like multiplication. So let's say we had this problem right here. The issue with this problem is that exponents always happen to or always operate on whatever they're directly next to. And the negative is only glued to that 5 with the strength of multiplication, which means if you think about your order of operation, what are you going to do first to that 5? Are you first going to do the exponent, or are you first going to make it negative? Well, if we follow the order of operations, the first thing that we've got to do is the exponent. So a negative 5 squared, written like this, would be a 5 squared, which is 5 times 5, but then we need to make it negative. Well, 5 times 5 is 25, and there's nothing to cancel out that negative. So the proper answer to this problem right here is negative 25. So exponents will happen before signs do, because signs tag along in that multiplication step of the pyramid. Now, on the other hand, let's say I wanted to actually square the entire negative 5. Then I would use parentheses, because the parentheses then would group that negative with the 5 more strongly and make sure that the exponent then applies to the entire thing. And so now I would end up with a negative 5 times a negative 5. Well, at that point, I know those two negatives are going to cancel. I don't really have to change them both to positive signs, but I know that they will cancel, leaving me with a positive 25. So we see something similar to this when it comes to units as well, which we'll deal with at a different time. So ladies and gentlemen, if I asked you, switching gears here slightly, what is the square root of 25? So remember that roots are the inverses of exponents, so we're undoing something here. So if I say the square root of something, then I'm asking basically what would you square to get 25? So I'm not asking you to square 25, I'm asking what would you square to get 25? Well, you probably just said 5. And if you said 5, you're half right. You're half right. Because as we just saw up here, we could also square a negative 5, actually square the negative 5 in parentheses like that. And that also gives us 25. This is what I like to call the true square root of 25. Turns out there are two of them. The true square root of 25 is 5 or negative 5. Now, ladies and gentlemen, typically when we're trying to find a square root, we don't bother actually writing out the word square root. Typically we use the radical symbol. So remember, the radical symbol looks like a half size upside down check mark connected to a division box. If I were to write this, however, radical 25, the answer is not 5 or negative 5. The answer actually would only be the positive 5. Because a radical does not actually give us a full square root or a true square root. Radicals yield, sorry, I before E, right guys? There we go. Radicals yield only what's called the principal root. They only yield what's called the principal root. So the principal root, though, is when there are two roots. It's the positive one. So the true square root of 25 is 5 or negative 5. You could square either one of those numbers and get 25. But the radical is only asking for the positive of those two options. And so radical 25 is just 5. So with that being said, let's say I were to ask you, what is the square root of 41? Now, unlike 25, which is a perfect square, 41 is not a perfect square. Perfect squares have the advantage of being the square of a whole number. And since they're the square of a whole number, they have nice square roots. 41 doesn't have a nice square root. And so the radical symbol can become helpful because the radical symbol then will give me at least one of my roots. Now remember that there's two roots here when we do an actual square root. We have the positive one, and so in order to get the negative one, we stick a negative sign in front of that radical. And so the true square root of 41 would be radical 41 or negative radical 41. This sometimes is shortened by using what's called a plus minus sign. It's really a positive negative sign, at least in this usage, but we often do just call it a plus minus sign. And so what this sign here is telling us is it's either a positive radical 41 or a negative radical 41. Now, these, ladies and gentlemen, right here, are the exact answers to the square root of 41. They're exact. Since this does not have a nice square root, it is going to be irrational, which means that unless we write it with symbols, it's going to go on and on forever without ever repeating. So as long as I use the radical symbol, I can represent the entire thing. And so one of the advantages to this exact answer here, is if I were working in a company and I had this as my result, I could leave that there and hand it off to someone else, and then they could decide what they wanted to round it off to. Maybe one department just needs it to the nearest whole number. Okay, so they pull out their calculator and they type in the square root of 41. They hit their enter button, they get their answer. So again, maybe one department only needs this rounded off to the nearest whole number, and so 6 is good enough for them. Maybe another department needs this rounded off to the nearest thousandth, so 6.403 is what they need. Or maybe let's say we're working in a department that's not so strict. We just need it rounded off to the nearest tenth. So 6.4, and the 0 would tell me it's going to round down. Everything else is just going to get chopped off into zeros. So 6.4. Well, ladies and gentlemen, the moment we round, we can no longer in mathematics say that this is still equal. We then have to switch over to the approximately equal to. So we could say that this is approximately equal to plus or minus 6.4. And so this would be our rounded answer. It's not exact, but it's more helpful because now at least it's written like a normal number instead of with the radical sign. All right, so ladies and gentlemen, with that being established, we're going to take a look now at the last part of our lesson, multiplying and dividing terms. Multiplying and dividing terms. And we're actually going to start with division. We're going to start by dividing our terms. So let's say we had 35 x squared y z to the fourth. And that will be over a negative 70 x cubed y to the fourth z to the sixth. So ladies and gentlemen, when you have something like this, it can be helpful to kind of split it apart into your mind into different pieces. And so when I'm splitting this apart in my mind into different pieces, I'm going to have a constant piece for my numbers, an x piece, a y piece, and a z piece. So if we look at the constants, we have 35 over a negative 70. Well, 35 over 70 is going to be a fraction. In fact, it's going to be 1/2. And since there's nothing to cancel out that negative, it's going to be a negative 1/2. As far as my x's go, I have an x squared and I have an x cubed. So we know that when we divide, we subtract our exponents. I'm going to show you just a little secret here. So if you were to subtract here, we'd have a 2 minus 3, which would give me a negative. If you want to avoid the negative exponents, just put your remaining variables wherever the higher exponent was. So if I treat this then like a 3 minus 2, I'm going to have 3 minus 2 is 1, but since 3 is bigger, I'm going to have my x to the first power down on the bottom. And we'll have a 1 up top. So essentially 2 of these cancel out 2 of those, still 1x left at the bottom. If we have y over y to the fourth, so again, this is really y to the first. So 4 minus 1 is 3. We're going to put those 3 y's where the bigger amount was. And then finally with our z's, same idea. So z to the fourth over z to the sixth. 6 minus 4 is 2, but we're going to put them on the bottom because that's where the bigger exponent was. So a z squared on the bottom. So if we put all this together, since I have a negative here, I'm going to put the negative out in front of my fraction bar. I'm not going to bother with the 1 on top, because if there's anything else on top, that 1 is just going to get multiplied with that and it's going to disappear. But I will put the 2 on the bottom. As far as my x's go, 2 of these will cancel 2 of those, leaving me with an x on the bottom still. My 1y will cancel 1 of my 3 y's on the bottom, or excuse me, 4 y's on the bottom, leaving me with 3 y's on the bottom. My 4 z's will cancel out with 4 of these z's, leaving me 2 more z's on the bottom. Well, and ladies and gentlemen, just as we did in each of these, if there's nothing left either in the numerator or the denominator, once we've canceled everything, reduced everything, well, it means that we're going to fill that with a 1. And so my answer here is a negative 1 over 2x y cubed z squared. All right, so let's check out another one here. This time we'll go with a negative 48 a cubed b squared c to the 5th power all over a negative 42 a to the 4th power b squared c cubed. All right, so ladies and gentlemen, I'm going to skip the red pen this time and just dive straight into it. So first things first, we do have a pair of negatives here. I'm going to just go boom, boom, cancel them out. No more negatives. Now as far as my numbers go though, I've got a 48 over a 42, which we know 6 goes into both of those. 6 goes into 48 8 times. 6 goes into 42 7 times. Now let's start reducing our variables. So looking at the a's, I've got 3 a's on top, 4 a's on bottom. So my 3 a's on top will cancel 3 of them on bottom. Leave me with 1 more on bottom. Or 4 minus 3 is 1, but it'll be on the bottom where the bigger exponent was. So we have just a single a in the denominator. A b squared over a b squared, since those are the same, we know they're going to cancel completely. So the b's are gone, no more b's. And then finally for c, I've got c to the 5th power c cubed on the bottom. So these 3 will cancel out 3 of those. So 5 minus 3 is 2, and the bigger exponent was on top, so the c squared will be on top. And there's nothing left that can reduce here, so that's my answer. Multiplication is a little bit easier, a little bit more straightforward. So let's say we had 3x squared y z to the 4th. And then we're going to multiply that with a negative 7 x cubed y to the 4th z squared. So similar to what we did in multiplication, we're going to break this apart into pieces. So multiply your numbers together, then multiply your x's, then your y's, then your z's. But we're going to just go ahead and dive into it. So there is a single negative here, but there's no other negatives to cancel that out, which means that the negative will tag along to the answer. 3 times 7 then is 21. And then x squared times x cubed. Well, a square times a cube. Remember, when we multiply powers, we add the exponents. So 2 plus 3 gives me 5. So I get x to the 5th power. Y is really y to the 1st power times y to the 4th power. So 1 plus 4 is 5. So this is y to the 5th power. And then finally, z to the 4th power times z squared. 4 plus 2 is 6. So negative 21, x to the 5th power, y to the 5th power, z to the 6th power. And ladies and gentlemen, that is the end of this lesson.